Good afternoon, students. So now we are going to discuss about a relation between electric field and potential. That is for class 12. So we are going to derive a relation between electric field and potential. So for that, consider a charge Q that is located at origin. Okay, consider two different points A and B. Okay, the distance between these 2 points A and B is very small. So I have written is at dr. Now we are considering these 2 points A and B this much closer that we are considering the same electric field for point A as well as for point B. We are not considering the different field for point A as well as for B, because these 2 points are located very nearby to each other. That is why the potential of, not the potential, the electric field of point A and point B is going to be similar. There will be a potential difference, as I already have taught you that potential depends on the location. That is why consider the potential of point A as V, and because there is a very less distance between these 2 points, that is why the potential difference between these 2 points is only dV. So this point B is having dV potential greater than point A. So that is why the potential of point B is considered to be V plus dV, and potential of point A is considered to be V only. And electric field, because of this plus Q charge, will have which direction? So always the charge is creating the electric field normally outward. So this is the direction of electric field towards the right side. Now students, suppose this is the direction of electric field and I want to have a charge and I want to move a charge. If I will move a charge from point A to point B, what will be there? I have to apply a force. And what will be the amount of force which I have to apply? The force will be given by Q naught into E, where Q naught is the value of charge, the test charge which I am going to move from point A to B, and Q naught into E. Here you can notice out there is negative sign. This negative sign is because we are moving the charge from A to B, we are going against the electric field. That is why negative sign we have considered, because force is a vector physical quantity. So we have shown this negative. Now students, so this is the force. Now when the charge will go from A to B, that Q naught charge will go from A to B, the force applied will be minus Q naught E. Towards this direction, the force applied will be minus Q naught into E. Now what will be the work done? We already know the formula. The work done is force into displacement. So force is Q naught into E minus Q naught into E, and displacement, because the distance between point A and B we have considered dr. So that will be minus Q naught E dot dr. So this is the work done. Now students, this work done we have calculated in the form of electric field. You can see Q naught E dr. Now students, same work done we are going to calculate not in the terms of electric field, but in the terms of potential difference. So that is why there is a formula for work done, that is a very famous relation you already have studied. So work done is equal to charge into potential difference. I hope you are aware about this formula. You can correlate this. V is equal to W upon Q. So what will be the value of W? So that will be Q into V. So W is equal to charge into potential difference. Now substitute the value. What is the charge? We are going to move from point A to B. We have considered charge Q naught. So Q naught into potential difference. What is the potential difference we have considered? That is VB minus VA. So that is V plus dV minus V. So what we will get? That will be dV. Okay, when you will subtract from this to this, you are going to get a potential difference of dV only. So that will be Q naught into dV. Now both are the values of work done. So both should be equal to each other. So students, we have kept both the values equal, and Q naught and Q naught gets cancelled out. So the value of E will be minus dV upon dr. Now students, this dV upon dr is known as potential gradient. Whenever there is a change of potential with respect to the length, so that is known as potential gradient. Suppose we have a wire and the potential of the wire here is 5 volt. Okay, we will travel little distance here it will be 4 volt. We are considering it only. So here it is suppose 3 volt, here it is 2 volt, here 1 volt, and so on 0. So we can see the total length of the wire, okay, and we can see the potential drop. Suppose this is 5 volt, this is 4 volt, and the distance between these 2 points is say 2 meter. So what is the potential gradient? How to calculate the potential gradient for this example? So we have to do this. Potential difference is 5 minus 4, and what is the distance? 2 meter. So that will be 1 upon 2, 0.5 meter. 0.5, sorry, it will not be in meter, so this will be in volt per meter. Okay, so this is known as potential gradient. The degradation of potential with respect to length is known as potential gradient. In the similar way, you can see that change in the potential is divided by dr, that is length, or that is the displacement of between point A and B. So this is known as potential gradient, and negative sign is also there. So we can say electric field is equal to negative potential gradient of, okay, electric field is negative potential gradient. This is a complete sentence. Or we can say electric field is the negative value of gradient of electric potential, or we can directly say potential gradient. So this is the relation between electric field and electric potential. I hope you understood. Thank you. God bless you.